All right, well, good morning again, guys. We're going to be talking about the comm and nav system, specifically the RMU, the radios, the GPS, so the equipment that we have on board. I know the courseware talked a little bit about the tasks. Remember, you're not responsible for that. And I know on the title of Lesson 206, it says that the GPS is not testable. I will tell you that is not true. There are aspects of it and how it relates to the navigation system that are definitely testable. And I'll go over in some sort of detail the things that you're going to need to know, okay? In addition, we'll talk about some abnormal operations. I will tell you overarching, if there's something that fails, most of this stuff is solid state, so if it fails, guess what? It's just like your ETD or iPad. It probably isn't going to work. So there's not a whole lot of troubleshooting you can do, but we do have some workarounds for that. UHF and VHF voice allows you to communicate to other aircraft and from your aircraft to any kind of ground agency. ATC, ground control, tower, you can talk to other aircraft. We have two separate radios. How many radios do we have in the T6? Two. How many radios do we have in the T6? Thank you. We have two ways to control the UHF and one way to control the VHF. But we have two radios. Most of those aft equipment bays have all of your radio equipment, your DME, your VOR tuner, your UHF and VHF, your flight data recorder, your aux battery. Most of that comm, your transponder, most of that equipment is stored in the aft equipment bay. For ease of use, we have the radio management unit, or RMU, which is where you can find most of your radio control stuff, minus the backup UHF control head. Sir, do I have to know all the frequencies? No. Just remember, ultra high is the really, really, really big numbers, and very high is the 100 range. The one thing that you do have to know is that the UHF receiver has dedicated guard. The VHF does not. If you need to talk on VHF guard, you have to tune that. But there is a guard receiver built into the UHF radio. And those are the frequency ranges for the VHF. So 243.0 is guard. Cut that in half. 121.5 is VHF guard, if you were curious. In addition to the UHF and VHF communications equipment, we have VHF navigation. When you tune a localizer or VOR frequency, and you have VOR selected for your navigation, you're going to get the appropriate display. So if you tune in a localizer here, you're going to get a display with localizer over here. If you tune a VOR, you're going to get a VOR display, provided you're in VOR for navigation. So to talk on the radio, on the PCL, there is a thumb toggle switch. If you push up starts with a U, you're talking on the UHF. If you push down, that's VHF. One ping only, please. Was it sonar beak? Sonar buoy? Too bad we don't have any Navy guys in here. They'd be all excited about that. All right. So there is a backup UHF control head. It's not a backup radio. It's just a different way to control our UHF radio. That exists in the front cockpit. If the RMU fails, if you have a generator or battery bus failure, or if your aux battery is the only source of electrical power, that's typically when you would use the UHF backup. I will tell you, generally, we use it on every sortie. it's preset to channel 18, which is the ATIS frequency for back here at Randolph. So in the area, when it's time to leave the area, you'll just turn on the backup radio, you'll get your ATIS, your weather information, and then you'll turn it off because it's already preset there. You don't have to change frequencies on your RMU. But that's where that lives. The controls on it, you've got the on-off button. If you push the knob, you disable the squelch. Who's used a CB radio before? Anybody? No one's used a CB radio? Nobody's from south of the Mason-Dixon line with the big antenna on your truck? Okay. All squelch allows you to do is it cleans up the frequency. If you turn squelch off, you'll hear the carrier wave, so you'll hear all of the static that goes with that frequency. If you turn squelch on, it gets rid of the static so you can hear more of a clean voice or whatever's being transmitted. The reason that you would disable the squelch is if you're having trouble hearing someone from a long distance off, you turn off squelch and you can hear all of the carrier wave. That's really all squelch does. You'll never use it, but I'm just saying that's what it does. The channel frequency, that allows you to go between the preset mode. If you press the red button, you'll go into a manual frequency input mode. That's all that does. The mode, it's got two modes. You've either got the main frequency, which is displayed there, 325.75, or you can go main and guard. It'll receive both that frequency and guard, but you're only transmitting on that frequency. $20 presets on the backup UHF control head. Remember, this cutout is in your testing cubicle. If you miss this question, shame on you, okay? The piece of paper even says CH20. There's 20 presets. If you press the little red button, like I said from the previous slide with the CH20, you get into a manual mode. So you can go in there and manipulate it with the inner and outer knob on the manual frequency button. Again, you can receive the main frequency or main and guard with this mode button. Let's start up here in the front. True or false, both UHF and VHF have a dedicated guard receiver.
False, VHS, yeah. VHF you have to manually too.
Only the UHF has the dedicated guard receiver, so false is the answer. How many presets on the backup UHF? You looked. Okay. He did, he looked. You guys could yell at him later. Yes, there's 20. The UHF backup automatically activates in the event. Yes, you have to turn it on. All right, any question on the radios? Two radios, two ways to control the UHF, one way to control the VHF, and that's on the RMU. ICS audio panel. Lots of words. Let me give you the Reader's Digest on this. Everything that's within this solid white line that's shaped like an L is cockpit selectable. What that means is you pull that knob out and rotate it, you're adjusting the volume, and you've selected that to listen to it. If you don't want to listen to UHF, push the button in, and that goes away. So all of these are cockpit selectable. Both this audio panel and the rear seat audio panel are exactly the same, except for this button down here, which we'll get to. The interphone switch, generally your hot mic between the two cockpits, so the instructor and student can talk to each other. It's got a rheostat so you can adjust volume. Under the audio, VR and both, those are for the nav source that you have selected. You can just listen to the voice capability, the Morse code for the identifier, or both voice and Morse code. We typically fly around in both, so you can not only ident the frequency, but you'll also hear the ATIS, because that's what the VOR at Randolph has, is the ATIS information. Norm and alt, we normally fly around with amplified audio. In the norm position, we have amplification. If it's in the alternate, we do not have amplification. You'll definitely see that again. And then this button down here is the marker beacon sensitivity. It's got a low setting and a high setting. Sir, what's the difference? One's low and one's high. Okay, that's all you need to know. In the rear cockpit, what is this switch replaced with? It's not marker beacon sensitivity. What is it? Hot cold mic. So typically the IP sits in the rear seat, and if for whatever reason the student gets airsick, he could go to cold mic. Now he will not hear the interphone between the two cockpits. When the student's done doing whatever he needs to do, you can go back to hot mic and then communication's restored. If during that time that the IP has the cold mic selected, you can still talk to each other. You just have to use the ICS switches, which will be here in a second on a build, and I'll show you those. This is in the rear cockpit only. So previous slide, you had the marker beacon. In the rear cockpit, everything's the same except for the hot-cold interphone switch. If the cold mic is selected, that means you can't just communicate normally by just speaking ambiently to each other. Then you have to press either one of these red ICS switches. They work identical except this switch on the front of the PCL mutes all incoming radio transmissions. So it's just communication within the cockpit. For example, if you're coming into land and you still have hot mic and or cold mic selected, and the situation is looking bad, i.e. the student's lined up with the grass and the tower starts talking, or someone's talking on the radio and it's really busy, the IP can reach forward and click the ICS mute button, mute all incoming comm, and say, hey, we need to go around so we don't crash. So that allows you guys to communicate. All right, but when cold mic is selected in the rear cockpit, to talk, you have to press either one of those buttons. Does that make sense? If for whatever reason you need to troubleshoot something on the ground or talk to the crew chief, you can give him the intercom signal and he'll plug in his headset. They have some out there. It's located right above where that little drop door access panel is to plug in the external power. So underneath his external power, if you rotate up here, that's the port to plug in the headset. We talked about what they do. Here's what they are. So you got UHF and VHF. Pretty straightforward there. Navigation, whatever you've got selected in the VHF nav window on your RMU. So if you've got this localizer frequency, if you pull out that knob, you'll hear the ident and or voice if it's got voice capability for that particular frequency. Marker beacon, if the approach that you're flying has one of those marker beacons, then you will hear the marker beacon tone in your headset if you have that pulled out. DME, if you've got a station that has DME, you'll also hear the DME ident. Interphone, like I said, is always active. Why? Because it's not inside of this L-shaped area. Remember, these are all cockpit selectable. I can pull that out and adjust volume or turn it off. This is always on, provided this is in hot. We talked about the VHF nav identifier, the bypass switch. Remember, normal is amplified audio. Alternate, you're not getting amplified audio. Marker beacon and hot and cold. Where'd I leave off? In cold mode, when are the interphone microphones active?
When you press the ICS key or the ICS key mute.
Yeah, ICS mute on the front or on the side, just the ICS button. ICS mute, ICS. Okay? True or false? With the audio control panel identifier in the R position, you'll receive both Morse code and voice. No, you have to be in both to get both. If you're in R, you only get Morse code. They tried to use trickery, you didn't fall for it. Good job. What controls set the interphone system to hot and cold mode? Yeah, down here, and it's only in what cockpit? Okay. Notice the courseware talks about that at length. You'll probably see a question or two on that. Okay. Any questions on the ICS audio panel itself? Pretty straightforward? Okay. RMU. How many fields are on the RMU?
I'm trying not to look at it, but 5.
Okay, there's 5. What are they? Do you know?
No. UHF, VHF, the VOR and
There's a blank one in there. Yeah, so we've got our UHF and VHF radios, which are the top 2. Then we have our transponder, which gives our ATC squawk code blank for future capability. Remember, this was an off-the-shelf Bendix King product, I believe, and then VHF nav. So those are the fields on the RMU. That allows us basically that one-stop shopping for our COM, transponder, VHF nav, all that stuff on one component. So it's pretty nice. Those are the display fields we just talked about. Field select keys. So if you need to manipulate some data in one of the fields, you need to select that field first. So if I want to change my squawk code, I select that field, and then I can manipulate the data if it's highlighted in that box. So those are the field select keys. The transfer switches, that allows me to bring a secondary frequency and swap here. It'll also let me adjust the cursor if I need to. Mode switches changes this portion of it, so you can go on, standby, and alt for the mode here. There is a mode key down here as well. Data entry, there's 2 knobs there, and the little one, inner one, also pulls out to manipulate the fine decimals. So it's outside, inside, and it still pulls out for the data entry. There's sub buttons down here, so page. Once I have a field selected, if I hit page, I get all of the sub pages for that particular field. For example, we had UHF selected in the previous slide. If I hit page, now I get to page 1. If I take this knob and I twist it, I go to I got close to it. It didn't like that. What did I do? Can I shrink it? I didn't touch it. Okay, so if I go to page 2, then I'll get that subpage. There's 5 pages on the UHF radio. Do you have to know that? No. But to get to the subpages, you have to first select that field and then hit page. DME Hold, that allows you to if you push the button on one frequency that has DME, you can hold it, it's displayed on your HSI, and then you can go and tune a different frequency. And we're going to talk about that here in a little bit. Ident, that allows you to send a brighter signal to ATC if they ask you for it. Everything's autonomous on the transponder. The signal will come and go as it needs to, but if they need to break you out of traffic, they'll sometimes ask you to ident so they can see a brighter return on their scope. Squelch works similarly to the backup UHF radio. Turn it on. If you can see the word SQ or the letters SQ, then your squelch is turned off. Normally you don't see that because you're using your radio the way you should. MEM, that allows you to use presets on the radio. 95% of the time you're going to use presets because you're flying in the local area. Ground is channel 1, tower is channel 2, departure is channel 5. West departure is channel 12. So you'll use presets primarily. You won't remember that ground's 118.6. You just won't remember that. Okay? But you'll know the presets. It's a nice feature. DIM, some of you messed around with the DIM function on the Systems 113. That allows you, if you press DIM, you can use the outside knob, and that changes the brightness fairly dramatically. The inside knob does it a little bit more gradual. So you power it up. What powers up this system? Does anybody know? Does it just magically happen? What turns on the RMU? Avionics Master, very good. So I turn on the Avionics Master and I power up our Bendix King RMU, and it goes through a series of self-tests. If you get to this screen and you're not patient, you can press return and it'll go back to the RMU. Wherever it was shut down last is what's going to be displayed on there. So typically it'll have 1/1, that's ground frequency because somebody taxied back to the chocks. Occasionally you'll have maintenance frequency or something like that, but it'll be shut down that way. If you just sit there with this screen and don't touch it, after a few seconds it'll revert to the screen anyway. So let's talk a little bit about the fields themselves. In the UHF, you've got your active frequency and then your standby frequency. So if I key the UHF radio right now, who am I talking to? 363.1. If I press the transfer key, what's going to happen? I swap frequencies, and now who am I talking to? There you go. So that's all that transfer switch will do for you in that particular situation. What does this mean, main? I'm only transmitting and receiving 363.1. Am I receiving guard at this time? No, I'm not getting guard. So AFI 11202 Vol 3 says Air Force pilots will monitor guard to the maximum extent possible. So this should normally be in what? Both. There you go. Now obviously if there's the shoot shop is doing some sort of test and the beacon's going off, mirror, mirror, it's annoying, then you should probably turn that off for a little while, then check back periodically during the sortie. What's up?
Do you have to hit the field select key before you hit transfer, or just transfer? Swap it.
You have to be in that field. Good question. Because it won't understand what you're doing if you're not in that field. Main, both, we just talked about that. Now I'm receiving both 363.1 and guard. But I'm only transmitting on 363. If I need to go to guard, how do I go to guard? I can do it a couple of ways. This way I just manually twist it in 243.0. The other way I can do it is what? If I have UHF selected and I want to transmit, I hit page, and that'll allow me to go in and get the radio into guard, excuse me. That is the preset. And if you're talking on that particular radio, you'll see the TX. If I was talking and pushing the button down, I would see a TX for transmit on that particular field. Squelch, like we said, if squelch is turned off, you'll see it. VHF works very similar to the UHF field. So if I have UHF selected and now I hit page, what's going to appear? Special function UHF first page will appear. Magic. This is where I can turn guard on or off. So if I need to talk on guard, I hit page. If UHF is selected, I hit that. Now I'm talking on guard and receiving on guard. If I need to go in and change what mode I'm in, I can use that key up there. So I've got some options there. When I'm done doing whatever manipulation I need to do, I hit return, and it goes back to the RMU the way I know the standard 5 fields. Tone, it has a capability. Most of the instructors know how to use that pretty quick, at least at the pilot training bases. When everyone makes a dumb radio call, they go page, tone, page, and then you'll hear a beep. Like someone will say, initial gear down. No, it shouldn't be that way. It should be 2 miles gear down. Someone will tone somebody. It's not very professional, but it's been known to happen. Supplemental pages in the UHF, pages 2 through 5, will be where all the presets are that correspond to those different frequencies. For example, all of those are loaded in there. Please don't go into the subpages and change the presets. That's just mean. Okay, that's what a Marine would do. They're mean. No, I'm kidding. Okay, don't go in there and change the presets. When you turn on the backup UHF control head, you're going to see the word remote appear on the RMU. It typically doesn't have a box around it, but you will see the word remote, meaning, hey, you're using your backup UHF control head right now to control your UHF radio. That's all that means. Nav indicator, whatever frequency you have that's active will be the system smarter than you are. It knows what frequency you have in that you've dialed into the active and can discern whether it's a localizer or a VOR frequency. So it's kind of nice. 108.6 usually will be like a localizer frequency. We're going to get to that here in a second. That's the active, and then obviously you have a standby frequency as well. The DME hold function, if you were to press and hold that, you get an indication here. Where else do you get it? HSI, where? Underneath the DME. You'll see the frequency that you, you'll see this. We're currently holding 112.3 with an H. You'll see what you're holding. So you get it in 2 locations. There's only 10 presets on the VOR. How many presets on the UHF? VHF. VHF nav. 10. And the standby? Or I'm sorry, the backup UHF control head? 20. What was the question?
You said 10 on the...
10 on the VHF nav.
Okay. There's an error in
Is there?
Yeah.
Okay. If you want to share that during break or whenever. Transponder. Pretty autonomous. You're given a squawk code, you can go in there and change the number. So as long as you select the field, it's highlighted, you can go in there and manipulate it with your data entry knob. There's 3 different modes. There's standby, on, and alt. The only 2 you'll use are standby and alt. On doesn't serve any purpose because it doesn't have any altitude associated with it. It's not useful for ATC. They want your squawk code and the altitude you're at for traffic deconfliction. They don't care that you're squawking 2026. They want to know that squawking 2026 is at 4,000 feet. That's what they care about. But standby, that just means that you're not transmitting. It's powered up, but it's not doing anything. On, you're giving your squawk code to ATC, but no mode 3, which is your altitude. And then alt means you're doing your squawk code with your altitude. Again, if you're interrogated, it's automatic. It's happening without your knowledge. There's one code that can be stored in the transponder. It's typically 1200, which you guys squawked the whole time at DOS pretty much. All right, Lieutenant Greaves, redemption time. What are the 5 fields?
Okay, UHF, VHF, ATC, blank, and then FE.
VHF nav, very good. That's like the 3rd time we went through that, so there would probably be something about that. Which combo do you set in the RMU for the UHF radio to receive on both active and guard? Yeah, you have to have it in both. If it's main, it's only what? Whatever the frequency is in there. So if this said main, it would be only 361 or 363.1. Both, I'm receiving guard and that frequency. How do I put 340.2 in? How would I do that? How would I make that the active frequency to talk on? Yeah, I have to use the transfer switch. So make sure this field's selected, transfer switch, good to go. Now, there's one other thing with this screen up. If I press and hold the transfer switch for 3 seconds, what happens here? The standby frequency disappears and I only have the active frequency. If I want it back, all I have to do is just press the transfer button one time and that will come back. Declutters it, especially in preset mode. If you had preset mode and all these frequencies in there, it gets really cluttered. So normally you'll go in there and clean it all out. So you'll have your preset with your frequency, and that's it. That's typically how we use the RMU. What's up? Question? Okay. We just did that. How do you transfer the standby VHF frequency into the primary position? There you go. You're like, duh, we just went over that. Notice VHF is selected as the field. You press it and it swaps these frequencies. Okay. How many UHF and VHF comp frequencies can be stored in the RMU?
20.
20. Correct. True or false? The RMU stores up to 5 transponder codes in memory. Uno. Only one. How many VHF nav channels are stored in the RMU? 10. Any questions on the RMU? All right, we're pressing along. We'll probably take a break in about 15 minutes. Bear with me. Okay, before I get into the nav stuff, this is not navigation class. So I'm not going to teach you how to navigate using the ILS, the VOR, any of that stuff. I'm just going to go through some rudimentary systems aspects of it. If you have specific questions to that, hit me up during the break. And I'll try to give you everything you need to know about flying the T6 for your entire time in RIQ. No, I'm just kidding. The nav aids. When we use the VHF nav, we can tune up to 3 different things. 4 if you count the TACAN, but I'll get into that in a second. There's VOR facilities. They're bearing only. So the white needle is going to point on your HSI with no DME. Then you've got VOR with DME. So it's going to point to the station and give you distance. A VORTAC is what we have here at Randolph. It uses a TACAN portion for DME, and obviously it's a VOR as well. So if the station's here and we're off here, it's the needle's going to point and give us DME if that is a VORTAC. Those are the frequency ranges for the VORs. You don't need to know that. They're all based on magnetic variation. There's a VOR DME, and then a co-located VORTAC, which is VOR and TACAN, which uses frequency pairing. So that's all VOR type VHF navigation. That last part where it had VORTAC uses the TACAN for the TACAN portion for DME. We can tune a TACAN that through frequency pairing to get just DME off of it. We have that capability. But for navigation-wise, those are the 3 you need to know. VOR, VOR DME, and VORTAC. I usually get asked that question, so I'm just nipping it in the bud. All right, localizer. Localizer is a approach mode that we have. When we select a localizer frequency, it allows us to have the deviation scale above and below glide slope, which is the up and down portion here, and then the localizer course, which is the deviation scale, white and pink, from center to allow us to fly a glide slope and a path down final to the runway. It's instrument landing system. These marker beacons show us where we are along that path. Typically, the final approach fix is the outer marker. The inner marker could be the missed approach point or near the decision altitude. Middle could be, most of them don't have a middle, but they usually have an outer marker at least. Glide slope is the vertical part. The marker beacon shows your progress along the path. Antenna, don't care where it is. The only antenna that's important, obviously, is the GPS, which is up on top of the tail, just like the roof of your car is where your GPS is for your navigation. So don't worry about the antenna position. Tuning for the VHF or VOR or VHF nav, depending on what you're using, is on the VHF nav panel. In order to go into approach mode, you must have VOR selected for navigation. Let me say that again. In order to go into approach mode, VOR has to be selected for navigation. So right now, what am I using for navigation? VOR. And I do have a VOR frequency, 116.3 selected. The station's how far away from me? 17.3 miles. And it's about at the 1230 position, so it's just a little bit right of my nose. So somewhere 17.3 miles away, that's my nav aid. Is this a to or from indication right here? Yeah, because it's pointing to the head of the green needle. The localizer frequency set in the standby, and if I was to press the transfer switch, what's going to happen? What am I going to see? These frequencies are going to do what? They're going to swap. What's going to be printed right here? Localizer. What's going to happen over here? I'm going to get localizer, and then I'm going to get a glide slope, and I still have my deviation scale across the middle. If I was in GPS, that would not change. I have to be in VOR mode to go into approach mode. So let's see what happens. Magic. So the RMU goes, oh, you put in 1093, beep, 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 beep. Yep, that is a localizer, so it displays this properly, and then this comes out as localizer. So tomorrow when you're in the Systems 211 sim, and you put in channel 1, and you go, okay, that's a VOR, and you see how that works. When you go to channel 6, which is the localizer, you're going to see it momentarily flash on the HSI. It's going to go localizer, and then you're going to get your glide slope presentation. So it's going to go into approach mode. Additionally, on the E80i, you're going to get glide slope. If it's got a marker beacon and based on your sensitivity you've got selected and you're near it, you may see that as well as your deviation scale. So all of that appears on your E80i.
Does the marker beacon change colors too based on where you're at?
It does on the bottom of the E80i. So if it's an outer marker, it will be blue. It'll start flashing. Then middle marker, I believe, is white. Then inner marker is yellow. It'll correspond to those colors that were up there. That's not important though. But yes, it will change. DME. DME is all about you to the nav aid. So that Starbucks cup is the nav aid. If I'm low altitude, it's pretty accurate. The higher I get, the less accurate it is, if that makes sense. So if I'm right above the station at 16,000 feet, I'm going to see 3 DME. Oh, because that's slant range. So it's directly from the aircraft to the nav aid. So further away, it's more accurate. This is what it's recording, slant range, for the math wizards out there. So yes, obviously the higher you get, the greater the error is on DME, or distance. Excuse me, not DME, distance. That's where it lives, back in the avionics bay. Where is it displayed? Where's DME displayed for us? Is that it? And if we've got it set up with VOR and GPS, we'll also see it down here for that particular station. DME Hold. This is how the functionality of it works. Just bear with me here. So the Brownwood VOR DME, which is that symbol right there, is where I'm getting DME for this approach. But the approach is a localizer. But the localizer signal doesn't have DME. It's using this nav aid for DME. So how am I going to do this? Well, I tune this first, the Brownwood VOR DME, which is 108.6, and then I press DME Hold. I get DME Hold here, and I'm holding DME from that. Now I turn in the localizer 109.1, and now I've got my course guidance down final. Just see how that works? I'm using one nav aid for distance and the other nav aid for my course alignment. You'll do that every single time you shoot the ILS here on runway 15 right. Uncle Sugar did not spend money on our instrument approach system. We use DME from the Randolph VOR, and the localizer has no DME. So this is the way you'll have to do your approaches here at Randolph. Over and Kelly, and 15 left. Big Blue did not spend money. If you go to other international airports and stuff, bigger airports, municipal airports, they typically have the deluxe model. They have DME with theirs. What are the three types of VOR facilities? Where I leave off? Sir?
VOR, DME enforcement.
Correct. What information does the ILS localizer provide?
Course guidance.
Course guidance on the localizer. I misspoke. Yellow is the middle, and then the inner is white. But it doesn't matter. It's kind of a nice visual depiction of it. If you're a picture person, if you can kind of remember this picture, it'll be very helpful on the exam, I think. True or false? During a localizer course information is displayed on both the EADI and EHSI.
True.
Yes, we just talked about that. You're going to have glide slope on the right-hand side on both the EADI and the EHSI. Course guidance across the middle on the HSI, across the bottom on the EADI. The only difference here is only the EADI has the outer marker symbolism. Symbolism. Okay. Boondock Saints, anyway? Okay, never mind.
The outer marker if you're in composite mode on the HSI.
No, you won't. You won't get the outer marker, because that overlay will cover up that particular display. So if you're in composite mode, you will not see that. You'll hear the tone still if you have the marker beacon pulled down. Good question. What happens to the DME display error the higher the aircraft is? Is it worse or less? Yeah, it gets bigger. We'll go through the transponder, and then we'll take a break. How's that sound? How it works. You're in your airplane. You're in Alt on your RMU, which is 4661 Alt. Your job's done. It's all automatic. The ATC interrogator shoots the aircraft with a signal and comes back. It gives a position update. It takes your altitude off of your front cockpit air data computer setting for your altimeter and gives that back via your squawk code. It's all automatic. You don't need to know there's 4096 codes. The reason that there isn't 9,999 is there's no number greater than 7. So if someone ever says squawk 7800 and you're going like this, stop doing that because there's no number greater than 7. There's some trickery on some of the instructors, so don't let them do that to you. Mode C, that's the one we're talking about here when you're in Alt. That gives your squawk code and your altitude to the reporting interrogator. The ident feature, because San Antonio is so congested with air traffic, on weather days especially, as soon as you get airborne and you check in with them, they're going to say, I got too much ground clutter. I got too many aircraft. Where are you? So they'll say Whiskey 37, that's my call sign, I keep using it. Whiskey 37 ident. And then you'll press the ident button, and for just a few seconds on their display, they'll get a bright return. They'll go, oop, there you are. And then they'll say Whiskey 37 radar contact, climb maintain, blah, 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 blah. Well, they won't say the blah, blah, blah. They'll give you some sort of clearance. There's the antenna. There's the box that goes associated with the transponder. True or false, you must press the ident button for the transponder to reply to an interrogation signal. False. It's automatic. It's like the Ronco rotisserie oven. Set it and forget it. Okay, there's a few TV watchers out there. All right, let's take a 5 or 6 minute break. Just be back in here. If you notice, when I took the break, collision warning, nothing on the task system, the traffic avoidance system. You guys aren't responsible for that. So we're going straight into the global positioning system, or GPS as it's more affectionately called. All right, the GPS. It's an off-the-shelf KLN 900. Like I told you guys in the very, very first systems class, garbage. Okay, it is a garbage GPS. The Navy bid off on, ooh, it's 900, must be better than the Garmin 580 or the 430 or something like that. No, but it's still IFR certified. It's what we have. You'll get used to manipulating it. It is not intuitive. And as we go through this, you'll see why. Remember that for GPS to work effectively, the time has to be accurate off the satellite. So it's 3D position plus time. So don't forget the time element on the GPS for it to work appropriately. Typically, a GPS works better the faster you go. I don't know why, but it's more accurate that way. That's more gee whiz. The antenna, like I said, is up on the top of the tail. It's on the top of the tail because it's the least obstructed area. Sir, what if you're inverted? Yeah, momentarily it's not going to matter. So you've got your GPS receiver display unit, and then it corresponds to the EHSI. It will show up. It'll have all of the data that you have. You can put any point in there that you need, but if you want to use it for navigation, how do I do that? How do I use that GPS for navigation? What do I have to do? I have to go to my nav source selector button and press nav to bring it into GPS mode. Now I'm using it for navigation. When you turn it on, it goes through a series of self-tests, and then it'll ask you if the date and time are current. If you want to approve something, you hit enter. You want to make sure that the database that you're using on the GPS is a date out in the future. If that date has come and gone, which is about the year most of you guys were born, then yes, you just acknowledge it. No, I'm just pretty close, probably closer to that date than today. All right. So yes, as long as that database is in the future, you can use it for navigation. If it's expired, you can still use the GPS, you just can't use it for navigation. So if you need to have someone run out from the squadron, load the little current database into the data slot, and put a new cartridge in there. When it finally comes up, it's going to come up with the airport page 4 and the nav2 page, its present position. The airport page 4 is the last known waypoint. So typically when you come back to Randolph, it's going to come up with that. So after it goes through its calculation, you accept it, you check the database, this will be the display that comes up. These are all the different pages that are available on the left and right side of the GPS. When you look at the GPS, let me go back. This line is basically the separator on the GPS display. There's information on the right-hand side and information on the left-hand side. Obviously, this cursor would control the left, this cursor and this knob would control the right. There are different page types on both the left and the right, except for there is a nav page on the left and a nav page on the right. That will become important when we talk about how you're going to fly around display-wise on the GPS. The inner knobs, once you get to the appropriate page, you can cycle through the sub-pages within that particular function. For example, on the flight plan page, there are 25 sub-screens. Those are your 25 different flight plans. All right, the cursor. If you press the cursor button, it's going to highlight the very first field. If you want to manipulate the data in that field, you take the inside button and rotate it till you get what you want. Then you take the outside button to move the cursor over and then manipulate the next letter. You can already see how fun this is. So right now it's a K. If you want to move it over, I take the outside knob and turn it. Now it's on the O. If I need to manipulate that, I take the inside and scroll until I find the letter I'm looking for. They work similarly. If I no longer want the cursor on, I simply press cursor and it turns off. So cursor to turn it on, manipulate what you need to, cursor, it turns off. Enter. Think about like keyboard entry on a computer. I got what I need, enter. It's asking me a question, approve it, enter. Do I want to load it in the flight plan? Enter. Message. This will rarely come up. Typically, it's for preset things inside the database itself or an error message. It's just your simple acknowledgement. Hey, you just crossed into airspace. Hit message. Our Sims, that's pretty much disabled. It's not going to do that. But it has that capability. If you see a message pop up, press message and it goes away. Save. This is also disabled. This would allow you to set current position. You just mark a point. You can save it into your data, into your GPS, and then rename it. It's a user-defined waypoint. Ours is disabled. Excuse me. Direct to. You use this all the time. So you'll find a point in your flight plan. In this case, it'll be Tuscola VOR. Once it's on that, you'll hit direct. It'll go to that point when you hit enter. So it's direct navigation. Clear. It clears out whatever data entry that was in there. Or you can remove a point in your flight plan if it's highlighted. It's kind of like a delete button, if you will, on a keyboard. OBS. You need to know what this does. OBS allows you to put a stake in the ground. For example, if I'm flying a flight plan and it goes from Randolph, over to Stinson Airport, over to Kelly, and I want to make Stinson OBS, I simply find it in my flight plan and I press OBS. OBS Omniberry Select makes Stinson the point in the flight plan that will not sequence to any other point. So I can fly over Stinson and then fly to Kelly, and it'll always stay on Stinson until I do something different. So it basically makes whatever you select as OBS an anchor point. And we're going to come back to that here in a minute if you're confused. But it allows you to take that active waypoint and define it as really a user-defined nav aid, if you will. Alt doesn't work. Don't worry about it. Nearest, you're flying it along in your T6. Everything's cool. You're looking at yourself in the mirror. Everything's great. And all of a sudden, your motor dies. Oh, where's my nearest airport? I simply press nearest, direct enter, and now my pink needle on my GPS, if I'm using it for navigation, will point to the nearest airfield. If I just go nearest, it's going to point me, at least bearing-wise, hey, your nearest airport is Hondo, and it's a 180 heading, and it's 17.8 miles away. So I always know where my nearest airport is. It's a nice feature. You guys will practice it in your emergency sims in the near future. Flight plans. If you've got your ETD handy, go to the in-flight guide on your Aero app. So under your, let me walk you to get there. I gotta back out. Excuse me one sec. So under RIQ publications, go flight, and then the very first one, 558th in-flight guide. On the miscellaneous tab on the right, the little blue one, press that. And then about 3/4 of the way down, you'll see GPS flight plan waypoints. Press that. These are all your canned flight plans that already exist in the system. Why do we have flight plans that are already built? It saves you a ton of time. You're welcome. We don't want you guys to go through that pain of cursor, click, 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 R, space over, click, 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 N, okay? We only have an hour and 15 minutes. You'd get 10 seconds of flying if you had to do that. So they're already built. This is what you need to know. If you were sleeping, you fell, he just said something, okay? You got to know this for the exam. There are 25 flight plans in the GPS. You can have 30 waypoints on each flight plan. And the active flight plan is always flight plan 0. So here's how this works. I'm going on a cross-country sortie to Midland. So I go in there and I load flight plan 10. So on the flight plan page, when it comes up with flight plan 0, I take the inside knob. Click, 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 10. Then up at the top, the cursor is going to say use. I'm going to say enter. I just loaded flight plan 10 into my active flight plan. It becomes flight plan 0. If I delete a bunch of points out of it, did I delete the points on flight plan 10? No, I can only manipulate the active flight plan, which is flight plan 0. Does that make sense? So I'm pulling them into flight plan 0, whatever I decide to do. So I take flight plan 10, make it my active now of flight plan 0. But flight plan 10 is still clean. A lot of students don't even understand that going through. I just wanted to take just a moment to do that. 25 flight plans, 30 in each one, 0 is your active. So how do we do that? On the flight plan page, once I scroll over to the flight plan that I want, that's highlighted use, I hit enter. I just loaded a flight plan in the system. And now it's flight plan 0. What if you saw a test fail, illuminate? Where did I leave off back here? Have we even talked about that? No. So what would I do? What happens if something doesn't work in your house? What do you do? Electrical. Turn it off, wait a potato, turn it back on. Let's see what it tells us to do. Look at that. Turn it off, turn it back on. That's an old B1 trick. Hey, this doesn't work. Turn it off. Now try it. Like I said, a lot of this stuff's solid state, so it probably won't work, but hey, give it a shot. It's electrical. Which GPS button is used during holding and non-precision approaches? Yeah, the OBS button. So think about holding. I've got an anchor point. I hit the fix, I go out. I hit the fix, I go out. Do I want it to go to this fix and then sequence to another one? No, I want to anchor it. Non-precision approach is the same thing. I got to know where the fix is, so as I overfly it, how far away am I from that fix? So we use it for non-precision, and for the reason I talked about earlier, if we want to put an anchor point or a user-defined anchor point in the ground, we use OBS as well. And yes, you will see that again, what the OBS function is. The active flight plan is always known as patient zero. Sorry, too soon? Yeah, that's too soon. We already had him. We have an instructor in RPAC over in the audit agency building where I work. And he's been sick literally for like 3 weeks. It started out as real bad allergies, and he just got a really bad head cold. So we've been affectionately calling him patient zero for a while now. So, but he is home quarantined at this point, so we'll see what's going on. All right. How many flight plans can be stored in memory?
25.
Okay. How many points in a flight plan?
30.
Okay. And the active one is?
Listed as 0.
Okay. There you go. I know it's a lot of words. We're going to go through it relatively quick. Okay. Very important. If you see dashes or off, what does that mean? Just throw it out there, somebody. It's no worky, all right? Unless it has what it's supposed to have, it's probably not working properly. And I'll give you an exception to that here in a minute. But if you see off or dashes, that's not working. If it's blank and the avionics master is on, then that unit's not receiving power for whatever reason. The display on the unit, I don't think you can dim it enough that it would be off. Yeah, in fact, I know you can't dim it enough to show it off. But some, like the GPS, you can dim it so dim that it looks like it's off, because we do that to students on low levels. So they actually have to look out the window, and the IP's got theirs nice and bright so they can figure out where they're at. Secret of the pros. What if you're trying to talk to your instructor and you guys can't talk to each other, can't hear him? What could be the problem? Cold mic could be selected in the rear cockpit. So try the ICS mute or the ICS switch. ICS problem, if it's truly failed though, that's going to be problematic. There is a checklist for that. If you can hear yourself breathe, but you can't talk to anyone outside the cockpit, you're probably radio out, which would be rare with an aircraft that has how many radios?
2.
Thank you. I'm going like this, so hopefully no one got that wrong. Nav failures. This is an AHRS failure, or automatic heading and reference system failure. In a lot of cases, if just the display goes blank, I can use composite mode, so I've saved the day. But in this particular case, if I was to hit composite over here on my EHSI, what would I see? I would see that same error display right here. So I'm going to have to do something. The checklist tells you to pull the circuit breaker, wait, and reset it. In the weather, that could be problematic. But what do I have to help me with this situation? I have a standby ADI. So my cross-check, instead of up to down, becomes down to up. So I just have a different display that I'm looking at. You're going to get X's over your glide slope or localizer if the signal itself isn't present, or if you're not within 90 degrees to the final approach course. You're going to see that if you're Johnny on the spot, getting all your checks done in instrument approaches, and you're going to see X's. Don't panic yet, but when you're getting vectored towards final and you should be getting it, that would be an indication that there's a failure. So if you see X's and off flags. If you see heading and or X's for the course or heading, then those are system errors as well. What does that mean, CP? That means one of the EFIS control panels isn't working. Control panel, EFIS control panel. That's the little flag. It's hard to see. So hopefully one of the cockpits, it'll work. So you can be directive. Hey, sir, I need you to twist in 270 for my course. Okay, if yours isn't working, and vice versa. That's probably a cannon plug problem. Honestly, it's got power to the unit, but it's not receiving any signal. The guys over in Iraq that are training the Iraqis how to fly the T6, they see these quite often because it's like 125 degrees there. So overheat conditions, the unit itself is getting hot. It typically gets hot from just being in the sun and the ambient temperature, and or if that fan that's behind the glare shield is not working, you'll get those as well. It's rare that you get that. This is the one caveat. Dashes might mean an error, but in this case, could it be an error? Or what is it? When am I going to see dashes up there? If I only have a VOR station. Remember, a VOR is bearing only. It only tells me where the station is, positionally. It doesn't give me any DME. So know what you're tuning. If you put in the Stinson VOR, which is over there, Stinson Airport south of San Antonio, and you put in channel 8, you're going to get a good ident. You're going to hear it, and the bearing needle is going to move. But you're going to see dashes up there. Oh, Stinson doesn't have any DME. It's a true VOR. So this is the one caveat to those dashes and off and X's. It may not have VOR. Or I mean, it may not have DME. We just talked about the GPS. You have to cycle power on that. Dashes in your transponder, that should always be a number. If there's dashes there, your transponder's not working. You may be relegated to stay on the ground depending on what your mission is required to do. If you are a pattern only or staying near Randolph, you may get special allowance to fly. Probably not, though. They're a little more type A now. So with an avionics failure, just like anything, we've got, I don't know, bless you. We got all these displays in our cockpit. Guess what? The rear cockpit has the same one. So if, hey, my VSI just went out. How's yours? Oh, mine's fine. Okay, it's probably the unit. If they both go out, probably circuit breakers, maybe the system itself. If it's an air data computer driven system like your airspeed indicator, that could be problematic. Check for those little warning messages on there. So circuit breakers are probably the biggest culprit. And if you can't recover that data for whatever reason, use your alternate. We don't have a backup VSI. We just don't have one in the aircraft. So the important ones, airspeed, altitude, ADI, those are all redundant in the aircraft. Not much you can do for it. Like I said, most of that stuff's solid state. Where did I leave off back there? Okay. You notice that your EHSI course indicator cannot be changed by rotating the course knob. What could be the problem, and how would you confirm it? You're rotating the course knob and the green needle isn't turning. You could see CP on your ADI for control panel, and your EFIS control panel is probably not working. That's what you'd see. Now, it could be both EFIS control panels, but rarely. There's only one mode that I know that would not be working, and it wouldn't matter anyway because you wouldn't see that display. True or false, the EHSI at the right indicates that the DME has failed.
False.
Yeah, it's showing 20, so it's not failed. What would it indicate if it was failed? Dashes, provided it was a nav aid that had DME associated with it. And we already clarified that. All right, back up here to the front. What indication on the RMU alerts you to a possible failure of the transponder? Okay, what else besides dashes? OFF. You could see off or dashes. Those would be indications that there's a problem. What's the first component you should check if you suspect an avionics failure? Circuit breaker. I would argue that you'd want to make sure that whatever power supply, i.e. the avionics master switch. I've been flying around, had my G suit unzipped, hooked the avionics master, turned, pulled it off, and looked down. I'm like, where'd everything go? Oh, avionics master. I didn't screw it up. But yes, circuit breakers is what you want to check with those type of failures. How are all the VHF tuning functions performed? The RMU. That includes your VHF navigation stuff and your VHF comm. Only on the RMU. What are the 5 fields of strife?
UHF.
Wrong. No, I'm kidding.
UHF, VHF, ADC, blank, and then VHF nav.
Correct. That's like the 7th time we've went through that. Just throwing that out there for you guys. What's the purpose of the ICS and the ICS mute key?
ICS if the rear cockpit is in cold mode.
Yeah, either one in cold mode you can talk. And what was the other thing?
The mute button is to.
The mute button mutes all incoming comm. That's what it's for. Nobody cares. You can say that. Go ahead.
On the vertical stabilizer, 202.
Yeah, nobody cares. Which ILS component operates at 75 megahertz?
Name marker beacon.
Boop, boop, boop. That's what it sounds like. That's free extra instruction that you guys got on that. Yes, the marker beacons. What's the range of the DME? How far out will it go?
199 miles.
199 Luft balloons, correct. What should you do if the controller directs you to squawk your altitude? What did you fail to do? Hey, squawk your altitude. You didn't turn it on. You didn't put it on ALT. You probably left it in standby or on. How do you select page types on the GPS? Correct. Page types are on the outer knob. All right. 35 questions on, I believe, Systems 2 exam. So you can't miss as many, but it's very straightforward. The Systems 211 is extremely helpful because a lot of it, without the tactile touches of going through it and go, oh yeah, that's how you, or I press and hold that, oh yeah, I see how that works. The courseware is not as intuitive as actually physically using all that stuff. All right, what questions you guys have for me? I think it's an hour and a half to take it. It's more than enough time, more than enough.